Alright guys, today we're going to go ahead and start our notes on 2-1, which is all about graphs, linear graphs. So a lot of this should look kind of familiar to you. Let me fix this for you. Alright, so here it says slope-intercept form. This should be a review for you. Y is equal to mx plus b. Alright, we're going to come back to this part here, but what does m mean? Well, this should be a review. M is our slope. Alright, our slope, okay, tells us the slant, okay, of our graph. You may remember slopes could be positive or negative, and we're going to be working with this today. All right, the slope is m. What does b represent? Well, b represents the y-intercept. Where it crosses, where the line crosses the y-axis. So you're going to remember this is the y, this is the x. So we're looking at where does it cross this line. That is going to be my b. All right. So the slope, very important in graphs, and same with the y-intercept. Well, this year we're going to be using this formula quite a lot. Y is equal to a parentheses x minus h parentheses plus k. So what we want you to start thinking about is these are very similar, but this you're going to use a lot when it comes to graphing this year and in high school. All right, so it's important for you to know this formula. My a, what does my a tell me? Well, my a is going to be very similar to my slope. All right, it does two things. Number one, it tells me if the graph, so it determines if the graph reflects, in other words, flips over an axis. And the second thing it does is it tells me if my graph is going to stretch, all right, get steeper, or if it's going to compress. In other words, get flatter, which makes sense because if we're talking about my incline, if we're talking about an incline on a treadmill, right, what would be harder to walk, this incline or this incline? So we're talking if it gets steeper, right, that hill's going to be impossible to walk. Or if it's less steep, if it's compressing, it's flatter, it's a little easier to walk, but still a challenge. All right, my H. H tells me if I shift left or right. All right, so that's my H. And my K, we're going to use this today as well. It tells me if I'm going up or down on the axis. All right, this is similar to my B. All right, so in case you do not recall from pre-algebra last year, the equation used to determine the slope between 2 points is y sub 2 minus y1 over x sub 2 minus x1. Go ahead and memorize that. Appreciate it. Love it. Also, from pre-algebra last year, you can determine the slope of a line by going from one point to another and counting the rise over the run. So go ahead and start that. Noting whether the graph is increasing from left to right or decreasing. Okay, so that's really important. So let's go ahead down here and write a few equations. It says, if the slope of a line is 2 and it has a y-intercept of -6, what is the equation of the line in slope-intercept form? Well, slope-intercept is y is equal to mx plus b. They're telling me my slope is 2, so y is equal to 2x, and my y-intercept is b, 2x minus 6. All right. If the y-intercept of a line is 7 and the slope is 1/2, what is the equation of the line in slope-intercept form? All right. Well, for this one, if the equation, okay, so y-intercept of a line is 7 and the slope is 1/2. Well, y is equal to mx plus b, right? My m is 1/2. Tackle on your x plus 7, so we have y is equal to 1/2 x plus 7. This one's a little bit different. It says if a line passes through 1,6 and has a slope of -2, so that's telling me my m, which means we need to find my b. So if I have y is equal to mx plus b, my slope is -2. I need to solve for b. I'm going to come over here and put x and y. Those are my coordinates. All right, we know it goes through that point. Well, if my x is 1, I'm going to plug that in for x, and my y is 6, all I need to do is solve this equation now for b, to solve for b. So I'm adding 2 to both sides. We get 8 equals b. All right, so I have my slope, I have my y-intercept. Y is equal to negative 2x plus 8. All right, so this one a little bit different. All we have to do is plug in our x and y, though, to solve for b, because we have our slope. Should be a review from pre-algebra. All right, let's go on to the next page. If a line passes through 1, 4, and 2, 3, what is the equation of the line in slope-intercept form? Guess what? We don't know my slope and we don't know my b, so I need to solve for those. Well, on the previous page, we learned we need to do y sub 2 minus y sub 1 over x sub 2 minus x sub 1 to get my values for my slope. So y sub 2 is 3, y sub 1 is 4, x sub 2 is 2, x sub 1 is 1. Subtract, you get negative 1 over 1, which means m is equal to negative 1. Am I done? No. Now I need to get my b. To do that, we're going to plug into the equation. So I'm going to use this first coordinate. Ms. Swiderski, does it matter which one I use? No. So if I have y is equal to mx plus b, my y is going to be 4, my m is negative 1, my x is 1. I'm solving for b. So I get 4 is equal to negative 1 plus b. I'm going to add 1 to both sides. We get 5 is equal to b. Well, if my b is 5, now I have enough information to put this in slope-intercept form. My slope was negative 1x, or negative 1, and my b is 5. So for this one, finding your slope through our formula, remember x coordinate comes first, then y, then plugging our slope back in and plugging those into the equation to solve for my b. Okay, let's show this next one. This next one says, if a line crosses the x-axis at 7, so let's go ahead and sketch this over here. Well, I know, sorry, that's a bad graph. I know this is my y-axis and this is my x. They're saying that this line has to cross at 7, which means it's got to be somewhere right in here. It crosses the x-axis at 7. Well, what do you think my coordinates might be for that point? Well, you might remember, if we're graphing this, we start in the middle, we go left to right first. So this point is going to be at 7, 0. And it crosses the y-axis, so somewhere down here, at negative 5. Well, what do you think my coordinates are for that? Start in the middle. I don't go left or right, so that means 0. Negative 5 is my coordinate for that. Now, this right here already tells me my y-intercept, which is my b. My b is negative 5. It crosses here at negative 5, right? We know my slope is going to be positive because if I connect those dots, it's going to be positive. But now I need to solve for that. So I'm going to go ahead and say, okay, well, y sub 2 minus y sub 1 over x sub 2 minus x sub 1 is equal to my slope. Y sub 2 is negative 5. Y sub 1 is 0. X sub 2 is 0. Y sub 1 is 7. If I subtract those, I get negative 5 over negative 7, or 5/7. So y is equal to mx plus b. My slope we just solved is 5/7 x, and my y-intercept is negative 5. Final answer. All right, I'm going to have you do number 6. We'll go over it tomorrow for our bell ringer. And now let's talk down here. Down here is where we're going to kind of incorporate everything we talked about at the beginning of this lesson. So graphing in slope-intercept form should be a review for you. All right. When I'm looking at this, you always need to make sure the equation is in slope-intercept form before you graph. First of all, plot your y-intercept, or your b. So in this case, my b is at 5. Use the slope as a rise or run to move from the y-intercept. Well, looking at my slope is negative 2, or negative 2 over 1. So for rise over run, it's a negative slope, so I know I'll go down 2 over 1. Down 2 over 1, down 2 over 1, down 2 over 1. Up 2 from my original to the left one, up 2 to the left one. I'm going to connect my dots and draw in these arrows. Remember, you're drawing those arrows in because you're indicating no matter how big or small my graph is, this line will go on forever. All right, let's go ahead and try this one. My b is -3. My slope is 1/2, which means it's a positive graph, okay, or a positive slope. So I'm going to put a dot at -3. My slope, I'm going to rise 1, run 2, rise 1, run 2, rise 1, run 2, rise 1, run 2. All right, now I need to do the other way. Instead of rising 1, I'm going to go down 1 to the left 2, down 1 to the left 2, down 1 to the left 2, and draw on those arrows. All right, I'm going to have you try number 3, or try this one on your own. All right, and we're going to go ahead and look at this number 4 real quick. For number 4, this is not in slope-intercept form. So to do that, you know slope-intercept form is y is equal to mx plus b. We need to get y by itself. I'm going to start by adding 6 to both sides. I now have 3y is equal to 3x plus 6. What do I need to do to get y by itself? Well, I'm going to divide by 3. So we get y is equal to 1x plus 2. So my b is 2. My slope is 1, or 1 over 1, up 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 1 over 1. Okay, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. All right, so that's that. Now, what I want you to do is pay attention, because this next thing we're going to go over kind of ties everything together. In algebra, we're going to be talking a lot about something called a parent graph. Okay, a parent graph, or as Mr. Dursky likes to call it, the original graph, the OG graph, okay? The original graph for this is y is equal to x. Ms. Dursky, what do you mean by that? Our original graph looks something like this. It goes straight through the origin, okay, where y is equal to x. So what we're always going to do is compare this original graph, right, where we're going up 1 over 1, up 1 over 1, up 1 over 1, so on and so forth, to all of these. To do that, we're going to look back in our notes from earlier at these variables, the a, the h, and the k. Today we're going to focus really on the a and the k. Okay, so if you look at this, I'm going to say, okay, well, what does this graph do compared to the original graph? Well, my a value is -2. So my a tells me that I flipped because it's negative. Okay, and my a is greater than 2. So if your a is greater than 2, that means, or sorry, greater than 1. Sorry, if it's greater than 1, that means that your graph is stretching. Okay, it's stretching out. And if it's less than 1, it's flattening. Okay, so A means it flips. Okay, it reflects, whatever you want to say. Reflect is probably better. And that 2 tells me that it is stretching from the original. And that 5 is telling me if it's moving up or down. It's moving up 5 from the original, right? Because that's my y-intercept. Let's look at this one. My a, it's not negative, so it's not reflecting, okay, which makes sense because it's going up. It's a positive incline. My a value is less than 1, which means my steepness is flattening or compressing. All right, and my graph is going down 3 from the original. Let's go ahead and look at this one real quick, and then I'm going to have you try this one on your own. This one, okay, let's see, we have 1x plus 2. So for this one, it is 1. So it's actually going to stay the same, the steepness, because my graph from here would be up 1 over 1, up 1 over 1. So the steepness is the same. All that's happening here is my parent graph, compared to my parent graph, it moves up 2. And we'll continue working on this next week. So go ahead and try this one on your own. And this is a little bit on 2-1 day 1.